The session is going to be on the title of Machine Learning Foundation for Linear Regression and Classification by Dr.V. Vijaya Rajan, working as Associate Professor in the School of Computer Science and Engineering, Vellore Institute of Technology, Vellore. He is having 18 years of teaching experience and has published more than 45 articles in the reputed journals. And his area of interest are image retrieval, ontological engineering, operating systems, formal languages and automata theory, wireless sensor networks, mobile cloud computing, machine learning and deep learning. And he has guided 3 PhD scholars and currently he is guiding 3 PhD scholars. He has received 1 external funding and 1 internal funding. On behalf of the organizing committee, WAIMS 2022, we welcome you, sir. And the session is yours.
Yes. Thank you, ma'am. Good afternoon to one and all. Happy Teachers' Day, first of all, to everyone. Now I will present my screen. Okay. Is my screen visible, ma'am?
Yes, sir.
Okay, ma'am. 1 second. It's actually. Full screen is not working. Okay. Good afternoon, friends. The way how I understood machine learning essentials, because it's a very good webinar, this series conducted by Gandhigram Rural Institute. Actually, I would like to give you a basic insight how to easily code and how to take data and then how to keep it in the platform and then how to apply machine learning models and then how to predict or classify the data. So those things we are going to see in this session. Maybe basically preliminary, but I enjoyed learning all these things, so I want to share it with you. I have given a title, the title I have given it as differently classification models for regression and linear regression and classification actually. So machine learning essentials. Artificial intelligence. Why people are very well talking about artificial intelligence? Because the machine learning, deep learning, all these categories, computer vision is going to be a proper subset of artificial intelligence only. Artificial intelligence, by book definition, any system that applies a logic and evaluates different options and make decisions on its own. Like that, the definition will be given, which means there will be a lot of logics will be there, algorithms will be there. There will be many evaluating if and else statements will be there, or advanced A-star like algorithms will be there. But the artificial intelligence, we are making the machine to take decisions. We will only give all logics to the machine, it will take the decision. It's simple like human beings, all visual cortex and system is how it is working. I'm watching a particular object before me. Sunlight is falling on that object and the rays falling on that object is incident ray is coming onto my eyes and then it is penetrating to my cornea and then falling on my lens. Backside of the lens, there is going to be the cells, rod cells and cone cells will be there. Those cells are going to understand the colors, texture, shapes of whatever the object I'm looking for. Then these signals are going to be converted into biological signals. They are going to touch my brain, and with my past experience, when I newly born, okay, this is going to be a purse. So very first time my mother or someone told me, because of that, whenever I am seeing the similar object, my biological neurons already learned this is going to be a purse. Like similar way, all the objects can be easily understandable by the human brain. But this artificial intelligence, our mathematicians and computer scientists are trying to mimic the human brain, and how to apply the similar intelligence to the machine and make it to think and to take decisions. So that is called artificial intelligence. Very simply saying, chess game. We know well that at the very first level, the chess game start with, we'll make a pawn to move one level or two levels at the very first move. After that, there are plenty of possible combinations will come. If you put it in Google, you may wonder 2 power 1, 2, 7, 6 number of combinations of moves will be possible. So how to feed, the very challenging part is how to feed all these combinations of move, and what is the opposite move. So that is being artificial intelligence. So we have to give the enough data to the machine so that automatically the machine will take decisions. So domain of knowledge domain in AI, there are many domains are possible. Deep learning, see machine learning related, deep learning, unsupervised learning, supervised learning, and then reinforcement learning is also there. NLP people working on wide research area, text generation, question answering, context extraction, classification, and machine translations like that, are expert systems under the artificial intelligence, or it may be speech recognition systems like speech to text conversion or text to speech, like our Alexa in our voice recognition system, how it understand and telling it to our TV, Fire TV sticks, or Google's boxes, how it understands. And vision computing, which is image recognition and machine vision like that, and planning and etc. These are all going to be a wide knowledge domain in AI, but a proper subset is machine learning under the artificial intelligence. So already recapping the same thing here, evaluating different options. In this slide, I would like to give search various optimization based evaluation technique. See, I can find a solution, many ways are possible, but in what way I'm going to apply the optimization techniques over there. So that is called going to be the evaluates different options was given. And note how to make a decision is told by the developer, but what decision to be taken is not given by us. There are many possible decisions can be taken by the system. This is AI. Now machine learning, when we are diving to machine learning branch of AI, that takes the decision based on data. And people are very well moving from not only machine learning to deep learning, transfer learning. Many things are going to come in the near future. Now deep learning is also a old technique as far as the vision computing people. Machine learning, here statistical formulas and models can be used. So there will be a data. So based on the features available on the data, the machine learning model is going to learn the pattern from the data. So and then it is going to, an unknown data is given, it has to identify what type of class it is it, or in the linear regression problems it will predict what is what. So this is what machine learning, but rather the case deep learning is the case called, there are deep neural network is being used. It is also one of the basic model called neural networks. So here more number of convolutions will take place. So types of deep learning will be CNN, convolution neural network, RNN, recurrent neural network, and then there will be some encoders models will be there. They are all the advanced level of machine learning. Now, machine learning by definition, Tom Mitchell in 1995, when he coined the term called machine learning. So performance on a task improves based on previous data or experience. So the performance, every time the machine learning algorithms accuracy, its performance is going to improve. So performance on a task, what you are going to do, that improves based on the data or experience. So if you provide a very robust data and noiseless data, there is no noise available in the data, then your machine will understand the patterns well, so that when the unknown data is given, it will predict it very well. So performance, task, and experience are the important keyword when we are defining machine learning, okay, by the book author. So that's why I put this slide. And types of machine learning passes through, it is supervised learning, unsupervised learning, and reinforcement learning. Maybe the morning session teachers might have given a wide examples about these three things. Maybe supervised learning, a small little example I will give, and then we will dive on to our research problem. So the example is identifying a Punit or some person So data with input and output is given. Very, very important in machine learning is that how the programming is going to differ from machine learning models. In programming, I will write a program, input will be given, supplied to the program. The program will try to generate the output. But here in the machine learning, input is also given, output is also given. That is called data or experience. So the machine should start understanding the input as well as the respective output, and it has to learn from the data, which means I'm having lot of statistical models here. In deep learning, we will be having neural network, deep neural network we will be using, and deep convolution we will be using. Here there are many models will be available. These are all statistical models. So if you know statistics, if data is given, how to handle data, if you know very well, then that formula or that equation will become a model. So we are going to build in this session, I'm going to build a model, new model. You see, using machine learning is very simple. There are packages available. You can directly go to Anaconda or Google Colab. You will feed the data, inbuilt functions directly. But as a computer engineer, I would like to engineer the model. Then this session is yours. I'm going to tell that. So the data with the input and output is given. That's what that line is telling. The learning is done from the data. So that is what the very, very important terms. Summary, the supervised learning, actually, I'll give the data. Data is a CSV file. So there will be data, can be a image data also. So a single image can be a row matrix representation, where pixel image can be defined by a function f of x comma y. Each pixel will represent some intensity value. That is image data. The actual data is going to be a CSV file. Most of the data, if you try to download, people will very well use Kaggle, and then our UCI repository or any other publicly available data sets, or researchers are using data sets are available here. If you download, they may be in some MB or in GB also. If it is a very big data, those data can be represented in the Excel file. Any Excel file, the data can be represented. Let me say a small example, like a student mark storing data, which will have register number and name of the student, and followed by mark 1, 2, or GPA and CGPA of the student for all semesters, subsequent semesters. For a 4-year course, 8 semesters, there will be subsequent data will be available. So every row will represent a particular complete data, and every column will represent, in database point of view, every column will be an attribute, people will call it. Here in machine learning, we will call each and every column will be called as a feature. So in this CSV file, if you find the last column will be in all machine learning model, in this CSV data, the last column will represent, which is I'm going to call y. Okay, x comma y of the data, the last column will be the output. The remaining n number of n minus 1 number of columns are all going to be the input. So which means with more features and everything, the final column will represent the either the classification output, or it may be a predicted output in the case of regression models. So that is what the first visualization about any data. Image data will be every image will look like a 512 cross 512 or 1024 cross 1024, like that. Then you can very well use OpenCV or MATLAB to upload the data, and IMRead function will help you to do that. So we create in the normal data, we are see data is available with input and output. I do not know mathematically, I do not know if I try to let me say a particular data which has some 5 lakh rows are there, and there are going to be 100 columns are there, 100 features are there. In that, even though I am a very good, excellent programmer, if you ask me to write a code and correlation between all these features, how the output is coming for each and every row, how the output is coming, if I try to correlate all these features versus the output and the data, it is very difficult for me to write a code. I cannot go beyond if-else statement. Even if I am writing first feature is going to be a student is pass if he got greater than 50 mark is one of the feature. Like that, there are many features are available. S grade is above 90 if it is in the absolute grading pattern, or relative grading pattern is completely who is getting the first mark relatively to that the normal distribution will fall. So all these things are it is very difficult for a programmer to capture the pattern from the data. Then people thought that what do we do? So in olden days, if you see any thesis done by before 1990s, there will be people will use statistical models to prove their data. The data is very robust, or it is a benchmark data set. They will apply chi-square test and statistical mean, median, mode, variance, like that only they might have used it, and then using that they will try to prove their data. But nowadays we are with good computing facility, excellent computing facility, and then we have good processor and advanced processors. We know machine learning. So what we are doing, we are taking those basic statistical models and their equations. Let me say a line equation, one line equation, y equal to mx plus c is more than enough to discriminate the 2D data. So above the data are going to above the line, y equal to mx plus c, m is the slope of the line and c is the constant intercept of the line in the xy 2D Euclidean space. So above the line there is going to be some class, and below the line is going to be another class. In that way, if I fit my f of x equal to y, so my f of x is y equal to mx plus c. Output, y is the output. I told that even though I have plenty of columns, the last column is y, remaining n minus 1 number of columns are going to be x. So each and every x as a parameter passed to a function f of x should map to a particular output. That's why every row will have some output over there. Now I'm going to use y equal to mx plus c model line equation, or if my data distribution is going to be e power minus theta, like that, it is an exponential curve, then I have to use that formula. Similarly, I have to go for first I have to visualize the data as a data scientist. If I know how the data is falling and I could visualize it with my experience on handling data, I may choose the model. I have to choose the model. So how to engineer this model, we will see that. So for example, our human brain in olden days will understand. My first teacher or my mom, I thank them, they have learnt me A means this, B means this, and this is called a red color, a white color, black color and green color, like that. So my brain neurons have understood all of them. Why in olden days we are not getting the memory loss problem? Because neurons are dying. So they are not fired whenever we are recollecting something. The neurons are dying. The only cell in the human body which cannot be recreated is brain neuron. The other cells can create and die, but brain cells, 70-gram brain cannot rejuvenate its brain neuron. So all these things are stored in my brain, could recollect it. So supervised learning, all the class labels are already given to my data, which means that if these features are there, then it will go to this class A. It will be class B, like that. Class A name will be perfectly given, which is going to be, let me say, it is going to be a red color, blue, green, like that. So whenever you are giving coloring like problem, automatically your machine should understand from the data and it should put it into that class. Is called supervised learning. So suppose how to find the odd man out here? It is a image data. See, all the patterns available in this rabbit with cat is similar, but you can find the color features are not enough for me to train the machine. So I need to go for the further level color texture. Somewhat the texture is look like same. the color is similar, texture is also sometimes similar, looks like similar, but some different pattern I could available. But shape features, when I'm coming, no, the rabbit's ear is somewhat different and cat's ear is very short. So if you try to add content based image retrieval content based content available on the image, then those features can easily extracted, and if it is being trained by a machine, any machine learning model, then it will predict is it a cat or rabbit over there. So unsupervised learning example is that it actually the data is given to you. There is no class discrimination is given, but you need to train the complete data to your machine based on some feature. Let me say I'm giving a coin mixing problem, mixed up all the coins and giving you to discriminate, but I'm giving a Romanian coin. You know the Romanian letters. If I give it in normal English 1, 2, 3, 4 like that, no, coin can be easily identified. Romanian character, if it is being written, then you cannot identify that. But only one thing is there, shape of the coin or the color of the coin I can discriminate. So based on color or shape I can discriminate. So unknown feature I will take it from the data itself and I will discriminate. Mostly the clustering algorithms will come in this picture. See, actually machine learning evolved from, even though it is under the class of artificial intelligence, it came from data mining only. So clustering algorithms will be here. So what fits the distribution and what does not fit it, based on that they will take it. So real-time examples are identifying anomalies in banking transactions, or solving the zigzag puzzle that starting from one position how to go to the home finally. Our children will play the game. Another one is reinforcement learning is nothing but the data will be available, but partial data available. So within the limited data, no data available, you have to build the data, and from that you need to give some reward point whenever you are going to train your machine. Based on that reward point, and you have to improve your model, is called reinforcement learning methodology, where the most of the gaming type of applications will come under reinforcement learning. So it is like how to ride a bicycle. At the very first stage, your backbone and your balance will not be correct, so you will fall down many times. But whenever you are falling down next time, how to balance it, your brain will understand that. Similarly, we will make a machine to understand that. So that is called reinforcement learning. In the similar way, whenever the baby touches very first time to the flame, it will wound the baby. The second time when it touches, curiosity will reduce for the baby. Then third time, fourth time, it won't touch. See, until the last breath, the child will understand that we should not touch the fire, it will harm us. So like that, the learning, keep on, the learning is happening on our human brain. Similarly, we are making the machine also to think. And real-time examples, riding bicycle or bike, or playing cricket at very first time, how to handle the bat, and how to 4 or 6, how to hit it, or playing football, how to make a goal from different directions, like that. So to understand machine learning, what is essential? Differential calculus is one of the basics. Let me say, ad hocly we can learn. After learning all statistical method and differential calculus, only can I come to machine learning? No need. You no need to study anything. Directly take a data. You can fit the data to the inbuilt function of a machine learning model, test it, and what coming, and then you can, whenever required, you can learn it. So we know in our school mathematics, y equal to x square is differentiated with respect to x, dy by dx. So what is this dy by dx is telling? Actually, when I am differentiating with xy, I'm trying to find the gradient of a particular equation or a function over there. Or I'm going to, if there is going to be a small difference in x, what will be the difference with respect to y? If I make it with respect to x, what will be the difference in y? So like time series problems and all, difference is calculus is very, very important. So x square is 2x. If constant is there, constant is 0, and this is going to be x is differentiated 1. So like that, or if it is given x square plus v square like that, 2x, because I'm differentiating with respect to x. When I'm v square is not having x, so automatically there is no x term, so it is considered to be considered as constant 0, and 2xv, so 2x will come, sorry, 2v will come with respect to x will 1, x will become 1. So these are all the basics, so you no need to worry about that. When we are solving the problem, modeling, we will see the further things. If suppose y equal to a function square will be there, then differentiation will be with respect to partial differentiation. Here is dou y by dou x will be 2 into that function, and each and every element inside the function should be to be differentiated. These are all basic mathematics, nothing else, you no need to worry. So the function was written as such, and then 2x and 0 plus 2v will come here, right? Now let us move on to supervised learning. So even though I have given linear regression followed by classification, first I will try to explore you and experience you what is classification with a simple perceptron learning algorithm, and then we will move on to linear regression problem. So supervised learning, we will take it. It can be divided into two class of problems. Regression, I will do hands-on from my side. I will show you, but anyway, in my material, everything is available. Whenever you find time, you can copy paste my code over there. It will automatically run on Google Colab or in your Jupyter notebook over there. And hands-on, you have been experiencing how you can do by yourself in the classification problem. So these two things. First, let us take a classification, and then I will come to regression problem. So I'm going to present a machine learning model for classification first, and then linear regression as the second problem. So here, the machine learning models for classification. Today's agenda, what I have taken is the example for machine learning. What is or what are the components of learning? What is a simple model which can be applied for any machine learning problem or deep learning problem, and types of learning available. All these things, types of learning, very simply we have seen, but with respect to optimization problem, what are the types of learning are available? Let us see that. So the learning problem, very, very important. The essence of machine learning. Many books and lectures, YouTube lectures will tell you where and all you have to apply machine learning, where should not you apply machine learning is very, very important. That is what the basic. Sir, because it is a new trend for my research, all type of research, may I use a machine learning? It is not necessary. Wherever you have algorithm, you can code it, you can supply the input, and you can test, and you will get the output over there. There is no need of machine learning. But I have a data with input and output, but I do not know how to mathematically pin it down. So the third point, we cannot pin it down mathematically. What is the distribution available on the data? There we need a machine learning. Second point, on your data, definitely a pattern must exist. Otherwise, it is very difficult. You are giving every time a random data, and you are trying to feed it to the machine to learn. All samples it is reading is indifferent. Then even though statistical model cannot make you to come to a conclusion what to predict or what to classify. So a pattern must exist in data. Third point is, without data, there is no business of talking about machine learning. So I have no data, but I know the logic means you have to go for programming. You no need to come for machine learning. You need to have a data. That is very, very important. Second, there must be a pattern exist. Third, I cannot write a program to find what is what available on the data. Data distribution I could not understand. Then we can't pin it down mathematically. So that is what very famous problem which was done in the years of 2005. A movie rating problem was introduced by Netflix company. Now also we are having Netflix on our home. What they have done is they had at that time machine learning was at the earlier baby stage. They have a movie rating before the movie is getting released. Now also we are having a rating of the movie, and YouTube comments and people comments coming out from the theater, everything we are listening. Here the movie rating problem, the Netflix company announced that they already have a machine learning model. They are having from 1960s to 2005 all movies, how it was rated by different persons who watched the movie, and also each movie was differentiated, well differentiated, how much amount of component comedy it has, or is it a blockbuster, or it is having many fight scenes are there, or there is sentiment is there, family subject, like that, many parameters, many features, everything can be with a numerical number. Here I have shown in the dotted lines. Big dot means more big component of that. It's an action movie. It need to be action movie, like that. Or otherwise, a numerical number, higher number will represent the higher way of that feature, possibility of that feature to be present in that movie. So every viewer, as I am a viewer, sometimes I may like Rajinikanth or Vijaykanth, like that actors, Kamal Hassan. So my view will be different when I'm not a fan of some actor. My view will be different. So every viewers are completely different on their basic feature of evaluating the system, and every movie is having, in reality, there will be some amount of features will be there. How much amount of comedy or action movie, like that, or which actor, also every movie is that. Now this movie rating problem, what we need to have, see, everything already rated data. See, if it is rating will be 10 scale or 5-point scale, it is given 4.2, 3.2, like that. So from 1960 to 2005, I have a all movies are rated with some number. My last column is output, but remaining n-1 columns are going to be, it's a comedy how much, or blockbuster how much, action how much, all the things are n-1 number of column features are with me. Now this Netflix is using some basic algorithm called perceptron algorithm. Let me say for an example, they asked the public domain people, you can take our data and you need to select the correct classification model, and if you improve our classification accuracy from 10% improvement, if you show, then you will be worth of $1 million worth prize money will be announced. So many people took that data and they have applied many different algorithms. They took artificial intelligence, neural network model, or they might be random forest model, or decision tree model, or support vector machines, or ensemble combinations of many models, many things they might have taken, and they try to prove the movie rating problem over there. Here, the very important, we need to understand the 3 points. One is definitely you have to give a data. Netflix has given a data. You have to have a data. Data is available. Very good. What is the second point I told was there must be a pattern exist. Definitely there must be a pattern. So every movie has its own pattern, and the viewer, how a particular viewer rated the similar kind of movie in his past history, it is called a pattern. So this viewer, suppose I am giving a letter of recommendation to all students to MS program in US universities. They will have my machine learning data. If so-and-so Professor Vijayarajan is recommending a student, how he will recommend, whether definitely substantially the student must work with him in a research paper, it should be published, or like that. I cannot, I will not recommend just like that, a student, ex-student studied on my class, just like that. So they know my data also. So similarly, a viewer already viewed all the movie patterns are available. Now the machine learning, how are you going to rate or learning? The real learning is how is it going to happen? So here we are doing a reverse engineering, that our input is available, output is available. From that we are going to take the pattern over there. So this is called a movie rating problem. Second, one more example for classification we can take very well. The problem is I can talk about credit approval problem. So this is a financial forecasting problem where, let me say, our Indian Bank of VIT branch has VIT started 1984, and 38 years almost we are running. And then we need to see the Indian Bank is also having many customers, maybe more than 8 lakh customer data is available with them. Now we are in 2022, 1984. In between, many customers or VITs were already bought a loan from VIT. He may be a professor or he may be a research scholar or a student. Student will get a loan, credit approval for education loan, or our scholars and faculty may get a loan for buying something. It may be a personal loan or any kind of loan. The past data is available with the bank. So the historical data available with the bank is 8 lakh data available. So age of the customer, gender, annual salary, how many years he is residing on the same place. Otherwise, you are moving from many addresses. You may fly away from the place and like Vijay Mallya or someone, you will go out. No, so Nirav Modi. So such kind of things, every bank will try to find how many years you are residing and years in job and what is your salary. Salary will play a vital role. A 15,000 earning candidate is, the bank cannot give a 20 lakhs loan over there. The repaying capacity, everything it has to look. So it has already given many loans for the past 36 years, let me say example, and many of them have almost some 80 or 90% have repaid the loan perfectly. But there are some 10% customers failed to pay the loan. Maybe they may be died, or they lost the job, or they may escaped, or some reason might be there. So they may not pay. This is the data. So I have a pattern of 80% of the customer who have well repaid. I have some 20% of the customer who do not repaid the amount. Now the question is, this credit approval problem is, unknown customer is coming with similar all data available, age, gender, annual salary, everything is available. Now a question is that how much can he is requesting the bank of some 50 lakh rupees loan for building a housing loan he is applying, whether can we give it or not. Mathematically and our computational wise, we have to tell it. So that is called credit approval problem. So the very essence of machine learning, any data you apply these 3 steps, then you go for, even for your research also, you look at these 3 points. Pattern exists, we cannot pin it down mathematically because 8 lakh data. So we cannot identify or write a logic to put it in your looping, checking if else, like that. And we have a data, right? The formalization, what are the components of learning? Very important components are input and output must be available. That is called data. We are talking about the experience, or data is input with output. And then there is going to be a target function, which is unknown always. The target function is unknown. But in the data, some statistical features are available. So my target function that I am taking initially need to take each and every data, it has to fit to my target function. So my target function's values are keep on getting changed, which is called learning. So I have 8 lakh data. Let me say one data, second data, third data, fourth data is being taken by the machine. It is learning the features. What is the input? Whether he has repaid the loan, yes or no, yes or no. Yes means repaid the loan, no means no. So all these features it is going to learn is called, I need to find the correct ideal formula. From 8 lakh data is feed on to my formula that I have taken. If it is fitted to my equation, then the machine converges, stops. So the data means, I already told that last column will be your output, remaining n-1 column is x1. I'm calling here x1 is the data, y is the output. Similarly, x2 is the data, y2 is the output. Like that, there are n number of customers, plenty of 8 lakh customers. I have a historical data. Now my hypothesis, see the hypothesis, the word we are we will use in machine learning, because here I am taking any hypothesis that this is my approximation function, so that the data is, when it is feeding, the hypothesis should approximate the target function. which is what input, what output is coming from all inputs, from all mapping of outputs. It has to approximate to the hypothesis that I have taken. So if my target function is f colon x tends to y, then my hypothesis will be g. For example, then x tends to y, I need to find out. So this hypothesis, initially when you feed one data, hypothesis slightly changes. Second data slightly changes, because the first data will say that repaid the loan, yes. So the values will change. If it is the equation is y equal to mx plus c, the equation line slightly slope and intercept will change, the line will fall here. Then it will try to get the second data, the slope and intercept changes, the line will slightly go up or down. So similarly, it will go like this. So reading all 8 lakh data, it will try to, the line will move out of all data points, which are x1, y1 is a data point. If I am plotting all 8 lakh data on a Euclidean space of x, y, now my line equation will adjust itself whenever it is you are feeding one data, it will go and stand in a particular place. And now you can say that the above customers are good customer who repaid the loan, and below customers are bad customer who did not repay the loan. So that unknown customer is given to the machine. It can easily understand that whether you can approve the credit or not. So that is the thing. Let us formalize or engineer the model. So this diagram will help you to, the unknown target function is f equal to x, y, and the training samples I am feeding. Now, very, very important point is the center point called the learning algorithm. So we have plenty of learning algorithms available. Let me say perceptron, or I may take the decision tree algorithm, or I may go to random forest algorithm, or navy Bayes algorithm, or any algorithm. So different learning algorithms are available. But hypothesis, every learning algorithm will have its own hypothesis. Every algorithm will have its own hypothesis. So for example, the hypothesis to explain well a quadratic equation may be a hypothesis. That formula, the hypothesis is a formula, or y equal to mx plus c, the linear line equation will be a hypothesis for linear data. Or it may be a quadratic equation of support vector machine to fit the data on the support vector machines. The support vectors are the closely falling points, data points on the classifier, the line over there. So soft margins you can easily identify out of them. So the hypothesis will have a formula. Sir, tell me a formula for decision tree. The decision tree will have a hypothesis called the entropy and information gain are going to be the hypothesis. So similarly, we are taking the unknown target function. When you are feeding the input data, the hypothesis formula, when you are fitting it, automatically your unknown function will be changing its line equation, or it may be any curve or over there, or plane equation in the support vector machine case, it will changes its plane. So automatically the final hypothesis will be approximated. So this is what about the learning problem happens on all machine learning models over there. And then for this credit approval, let us formulate it and let us run the model, how the classification is very well being done over there, that we are going to see now. The solution components are hypothesis set I need, whether you are going to use only one hypothesis or only a line equation y equal to mx plus c, or you want to have more number of equations like y equal to e power minus x theta, or some other plane equation or anything. So like that, accordingly your learning algorithm will change over there. Then finally you are going to find the hypothesis over there. Now formulate it. Suppose I am using a very basic level perceptron. So perceptron is a simple artificial neuron kind of classifier. Okay, the biological neurons in our human brain, now people are going to model it as an artificial neuron. There will be an input and there will be output, and then there will be a bias will be given to that. Like that they have model. One human brain neuron was modeled to artificial neuron. So in human brain, the scientists are thinking that, engineers are thinking that, or everyone are thinking, there will be some input layer will be there, then there will be some hidden layers will be there, some processing will happen in the hidden layer, the output layer will give you the classification output. I'm seeing my friend, someone is walking very far away, my eyes are closely watching. My human brain is not getting the complete feature, but it is remembrance of one of my close friend. His walking style is some X person is coming, but my feature extraction to my eyes are not clear. When he is coming closer, oh, this fellow only wear like checked shirts, or his pattern will be like that, his gestures will be like that. Coming closer, more features are fed onto my human brain. So now I can say that my ex friend is coming. So like that only everything. See, the computer vision and human vision is mostly similar, because anything that I am imagining, my good olden mathematics class in my school days, if I am imagining, it will come like a video in my human brain, either video, or I'm thinking about some person in my mind, or I'm thinking about a Lord Muruga God. I'm thinking it will come in my, an image will come. How I initially perceived him, in that way it will come. So all these things are image or video. So that type of data can be easily handled by machine learning or deep learning models over there. So I'm working closely to the computer vision problems. So a simple hypothesis set to the perceptron is a basic model. For example, here the customer inputs are going to be X1, X2 is an second customer, X3 is third customer, 8 lakh customers are available. We have to clearly understand that X1 consists of age, his salary, many parameters, but Y consists of only he is a good customer or bad customer. So output column will be a single column over there. Now approve credit, my credit approval formula will be, I'm going to give some weightage to each and every X parameter. See, Xi, if I give I is equal to 0 or 1, here it is 1, in the first formula, I equal to 1 to D number of features I have. One is age is one of the feature. So age may be within 30 years, within 50 years. A person, if I am giving a loan to a person who is at 60 years old, applying for a 50 lakh, he may die. Possibility of dying is very quick, and he may be retired very soon. So he cannot repay the loan. So weightage you have to give each and every features. So all the sum, X1 features weightage plus X2 features weightage will be the weighted sum. Will be, I'm checking with the threshold. That threshold may be a salary, or it may be age, whatever it may be. If it is greater than that, then you can approve the credit. Or if it is less than the threshold, the salary is not greater than 1 lakh, you don't give a loan of 50 lakh per month. I am telling, per month 1 lakh customer only will be allowed to take a 50 lakh loan in a single pay. Then like that, approving or denying, if you are taking. Now I have to make it as a linear problem. So what I'm doing is the linear formula that I'm H equal to, so my hypothesis, there are plenty of hypotheses available, different models are available. My hypothesis that I have taken as a linear line. So from this data, x1, it is a polynomial equation. So that is h of x is sine of summation of I equal to 1 to d wi comma xi. See here, greater than or less than symbol. Simply if I change it to minus threshold, if this right hand side value is positive means, then which means the first number is greater, which means the first approve. Or if this is lesser, then it is a second. So you will get the sign is my important parameter in this line equation. If positive sign or negative sign is it getting, based on that I'm going to tell that he is a good customer or bad customer over there. Now a simple hypothesis set, the perceptron, is how it is going to work with this is, let me take in this diagram, the purple line is telling the classifier or the hypothesis. The hypothesis I have chosen is the previous formula, this formula h of x sine like that. And now see, all computer arithmetic start from 0. So what I would like to add is that the multiplication identity is 1. So I would like to start from I equal to 0 to d. so that I can go up to n minus 1. Even I'm writing a for loop like that. So xi comma wi comma xi I have taken. Here I have added the multiplication identity 1. X naught is 1. So x naught w naught, I have started it with that. So automatically, so I can represent only this. I no need to represent this. In this, the purple line is the hypothesis or the equation. Now the plus symbols are the good customers and minus symbols are the bad customer. In my data, I have 5 good customers and I have 4 bad customers on my data. Now initially my hypothesis line may fall on any place based on my intercept and the slope of the line. It may fall on any place. But after, see, the complete data, input data that you have taken, h of x is equal to sine of wtx. So why w transpose of x we are taking? Because matrix multiplication will go like all rows will be multiplied with the column over there. So the transpose I am taking and multiplying it with. Now a simple perceptron algorithm, if I am using, you no need to worry about what may be the algorithm. You can see, first understand the concept, later any algorithm you can easily understand. The perceptron, if you implement like this, so h of x is sine of this thing. Sometime a particular point, data point in here, see, I would like to bring final output like this. After the machine is learning, the purple line should perfectly separate the positive customers to one side, negative customer to another side. Like that I have to bring. But what is happening here, the initial drawing of my line is some bad customers are at good side, one good customer is at bad side. So if it is there every time, so people are calling iterating, one by one data is being taken, so that my the slope and intercept is going to change my line for my line equation, and I am adjusting the point to go. Bad customer should on the good side should go to his side, or the good customer on the bad side should go to its respective side. So like that. So each and every misclassified point, while I'm running one iteration, and then second time when I'm running for the epoch, people will call it as epoch, second epoch, third epoch. So the adjustment will keep on happen. At a certain point, conversion is that no more misclassified points are found out. The data was completely learned. So there will be some error will be there when the machine is going to learn. How to define the learning error is nothing but whatever the data you are feeding to the computer machine, the error is nothing but the difference between the predicted output with the actual output that which is you have taken on your data. So that difference is called error. People will call it a simple error or mean square error or some other term they may use it. But the difference between the machine learning prediction versus the actual output you need to compare, and that is called. Accordingly, the weight vectors are going to be updated. So that is what shown here. The weight vector will keep on changing. At a certain point it will stop. That means there is no more updation is required. The machine learned. Now you can give any unknown input. Automatically you have given the 8 lakh customer data to the machine. So you are giving 8 lakh to 1th data for validation. Automatically it will say that he is a good customer or bad customer, whether you can give a credit approval or not can be decided. But when 8 lakh data is available, normally we will not learn the machine completely the total 100% data for learning. So we will be having 80-20. The split will be 80 for training and 20% for testing, or 70-30 or 60-40. It depends on, okay, empirically you have to choose it. And there will be a false positive, no, false negative, true positive, true negative, which is called a confusion matrix also. After the machine is learnt, you need to find out. In the simple perceptron with 9 data available, there is no error, 100% it is perfectly learnt and no error available. But you have more data, definitely there will be error rate will be some 2% or 3% error rate will be there, or more number of error rate will be there. So now everything is done. You have a data, and you could not pin it down mathematically, so you used perceptron learning algorithm. The algorithm steps are one iteration of PLA will go W tends to W plus yn xn. So automatically this is the formula that we have taken, and every iteration it will pick up the misclassified point from first data to 8 lakh data. It will run, and then in the second epoch it will take another misclassified point, fix it. So like that, no more misclassified points are available. Then if the line is slightly move here, then the positive will go to this side, but at the same time some negative should not go to this side. So whenever you are running to correct some data point, another data point may go to wrong side. So that's why we need to run many epochs and find at a certain point no more changes happen, so the machine is learnt over there. So this is called the classification problem. What are the different types of models are available, and their hypothesis available? Multi-layer perceptron model, so neural network model, so bias weightage can be a hypothesis. You can take radial basis function of neural network, then you can use a quadratic equation, or support vector machine quadratic equation. Radial basis function feed forward network, you can use it, or a single decision tree. You can use hypothesis as entropy or information gain, or decision tree algorithm, forest also. Deep learning and transfer learning, where I have already learnt my machine. I don't want to give my data, but my learnt values and some of the partial layers can be given for the further researchers to research it. Suppose I'm having a hospital data, my learnt layers, some of the layer, from that layer you cannot get my complete data mapping, you cannot get it, but you can use them for training your further data over there, which is called transfer learning. You can take it. And there are some classification optimization algorithms which is being taken from biologically inspired learning algorithms for classification. So here people will use optimization functions, are generally convex or non-convex, people will call it. So function having unique minimum, which means only one minimum available, then it will converge very quickly. Minimum means my aim is to find a minimal value for optimization, then that is called minimum, which means my search space, within my search space, what is the minimum value? Or non-convex function having more than one local minimum will be there. How to explain it very clearly? Suppose let us assume there are many horses are eating grass on a grass field, of very huge grass field. One horse will think that let us assume every horse is knotted with some rope and it was tied with some pole over there. Then the radius of the rope only it can eat the grass. So that is called local minima. So within that only it can eat, but the horse will think that there are crowd is there at some distance place, so more grass is there. So there will be more grass available, which is called more than one local minima available. Like that you assume. And the following statements are true related to the convex minimization problem is if one local minima exists, there is a global minima, or the set of all global minima is convex. And for each strictly convex function, if the function has a minimum, then minimum is unique. So some of the algorithms, machine learning algorithms, are suffering from local minima. Let me say our artificial neural network model is suffering from local minima problem. So it will not converge easily. It will stuck up with local minima. So people may, for the taken input data, they may move to another machine learning model over there. And global optimization is a NP complete problem. See, any problem that can be solvable in a polynomial time is can be measured with big O, big theta, like that. If you could not solve the problem in algorithmic time, then you have to go for NP complete or NP hard problem. You have to apply a trial and error or heuristics approaches you have to apply, or genetic algorithms based or particle swarm optimization, stimulated annealing, or you can use Firefly algorithm. Many optimization load balancing algorithms are available, right? Some of the existing biologically inspired algorithm, the bee colony, ant bee colony, Firefly, and many other algorithms are Fox algorithm is also there, or Eagle algorithm. Many researchers have created plenty of optimization algorithms are available. Now we will move on to linear regression. So the classification is very well where the classes in the previous problem I have used the binary classification problem. You have to say good customer or bad customer. Multi-class classification problem, similarly there are more than one class available, so you have to use the same approach to find the which class it will fall under. And linear regression model, suppose I'm asking a question in a car race, we are all watching, I'm asking my friend what is the speed of the car every round it is going. He cannot say constant output. It is going in an exact output, 80 km speed or 120 or 200. He will say that the speed may be varying from 180 to 100 or 120 to 140 like that. So how to find which data are applicable for regression or linear regression is the continuous data, which means they are not discrete. If your data is discrete, which means that I can say each discretization is going to be a class. If there is no discretization, then similarly you are going to sell a house. So your house selling problem will be square feet and everything, where the house is available, how many square feet, everything you will, and how many BHK, 1 BHK, 2 BHK, 3 BHK, like that. Then you will be telling that 35 to 50 lakh. Depending upon the build quality and everything, but you cannot fix a certain price. Bargaining will happen between the seller and buyer. So all these things are going to be called as what? We are calling it as the thing is called the house price the linear regression problems. They are all. Now let us model how this linear regression problem. It's an interesting problem. I'm going to show you a data. This data will be given to you after the session is getting over. The organizers will give you the data to you. So here the different sizes of the houses are given, and the prices, actual prices are given. Here this is called a univariate data. As I told earlier, any CSV file is given to you. Last column will be the output and remaining columns are input. Here two columns. So this is the X column, this is the Y column. So that is what the model I have shown. X, comma, Y, D data set over there. So 500 square feet is 6.3 lakhs. Here amount is shown on lakhs over there. Suppose my data is going to be more than one feature. Let me say I'll show you more than one features like that. See whether the last column will be the sale price. 76 lakh or 2 crore 17 lakh or like that. Remaining columns are all input, my total X matrix. So one of the feature can be square feet, how many square feet it is, or distance from main city, or it may be how many bedrooms, single bedroom, double or triple, or how many bathrooms you have, or any other rooms are available, parking facility available, building quality. Or so like that, your data will be any of these two category only. Any of your visual data, normal data, numerical data will be look like this only. The last column will be the price. If I'm giving my machine these features as an input to my machine, so it has to learn the patterns. So if it is 1182 in this range and it is 6711 all the values, then the price is this. Like that, many different patterns are available. So I cannot write a coding to capture these patterns, and my single program cannot tell prediction over there. So I will take it as a data, X data and Y output. Now we are going to use the linear regression machine learning problem here. So the output can be predicted as a continuous output. My prediction is also maybe it is a range from 72 lakh to 85 lakh, like that. I have to predict it because regression is a continuous problem. I'm going to give my output also. So here it is linear data. Anyway, numerical values are going to be mapped to some output, which is also a numerical output. Sometimes your data may have a categorical values, whether gender also can be inside there or something in different data. So if a mixture of all these things are there, they are called categorical data. So you need to convert each and every categorical values into numerical values, so that for computation it will help us. The machine can easily understand the data over there. So that is what. So my function f of x, this x is nothing but all features that I have taken are a single feature in the univariate data. All the house sizes will be given, and the y will give me the output over there. So that is what is the simple machine learning steps to apply the algorithm. So first of all, I need to have a data. Second, I have to visualize the data. As a data scientist, I can say that what type of hypothesis or the machine learning model I can choose. Unless otherwise I could not visualize the data, I cannot, then I can go from basic machine learning model to all machine learning model. So that is mere time waste. So for that purpose, I have to have this, and then I have to define my model over there. Then once my model is okay, next important step is, if I use this model, how come my data that I have taken is going to be learned by the model, whether what is the error. Error is the difference between the predicted output with the actual output taken on the data over there. And that is called the cost function in machine learning model. Now, I need to find, I have to make the machine to learn from the input in a gradient manner, the gradient descent manner. So which means that the gradient descent function is a optimization function which should make me to move on to a positive direction, so that my error rate will be very minimal. Otherwise, whenever you are adding more data, when I'm learning, the model's output should not go, the error rate should not go beyond, it should not increase. So that is called gradient, help of gradient descent, and minimize the error to get the optimized parameter values, and test the accuracy of the model, and then we will cross validate it, and then we can predict it. So that is what we are going to do. So stick with me. So f of x is equal to y is my function. So x, I am going to pass all my historical data except the last column. I am going to pass over there. So that is what I am going to do. Now for my new input, once like that the machine is learned, any new input is given, it should tell the new what is the actual output over there. So x new will give the y new over there. So once my model is robustly built like this, I will get the output. So slowly let us move on to. So first step is to visualize the data, so that I may understand that it is a linear data, means then simple line equation y equal to mx plus c is more than enough. And if you represent it as for example, x will be theta naught, this m and c are the changing parameters. Okay. So the varying parameter in the equation, in the hypothesis. So m and c, so theta naught plus theta 1 x, like that if you take it, then suppose my distribution is like that, my data distribution. So I have to visualize the data. Let us see how we are going to do. Y equal to e power minus theta x is there, then the above the lines are one prediction, below the lines are going to be another prediction over there. So to do this, I need to have packages available on Python program. So Python will help us easily to operate with this. So numpy, pandas, matplotlib.pyplot. So are these three packages. NumPy will help you to identify the mathematical calculations. Pandas will help you to get the input from the data and your CSV file to be taken, and manipulating the raw data like that are available with pandas. And matplotlib will give you the graph over there. With that only I am going to visualize the data. So all these three things can be taken by the import numpy as. See, because if I am using import numpy is more than enough. But if I am every place I have to type numpy or pandas. So I am minimizing it as np pd. So hereafter I may use it as np dot the function name available, or pd dot matplotlib as plt. Plt dot means matplotlib.pyplot automatically will come. So these are the libraries. So before that, I would like to show you the univariate data of a single x and y. This is also given to you. You can very well see the first 3 steps are saying me to use like this. So I can take Google Colab, and the Google Colab or your Jupyter Notebook will have a cell type of formats will be there. So each and every cell you can type one command over there, and then you can run it separately also, as a whole also you can run. I can type all the 3 things and I can run as a single command, or I can type each and every line interpretation wise or compiler wise I can run it. So if there are no more errors, you will get it will come to the next cell over there. My next step is to feed my data. So my data, I'm keeping it as /users doctor is my computer name, and desktop, and Chennai _ house _ univariate training data .csv is my file. So automatically, see, nowadays not only the assignment operator equal to is going to be used to store int a equal to 5, means 5 is assigned to I. But nowadays, the int I can even store, not int I, the I can be used to store a particular complete CSV file also. So that is what the advantage of the Python. So I can take the complete CSV file. So my CSV file will have totally how many columns are there? Totally 97, because the first column is taken for the feature name. So 97 inputs are there. Totally 97 inputs are already taken, and it was stored onto the single variable called raw data. Let us go to my presentation. Where is the presentation? Sorry. Here. Yeah. Now, see, your Jupyter Notebook will look like this. If you install, there will be a plus symbol will be there. So every time whenever you are using plus, you will get a new cell over there. And then how to import the input. So the importing function shown here is the very old method of getting the input and read CSV, and the complete path need to be given. But nowadays Pandas is helping us a lot to how to read the data, how to easily read the data. So the function here. So that is PD, because already I defined Pandas as PD.read _ CSV, so that it can easily help us to read the data. After that, the third function that I am going to use is, once my data which was loaded onto the raw _ data is perfectly loaded or not. So I have to check that one function is available in Python, that is called raw _ data is the variable name of the CSV .head. The head will give you 10 inputs that loaded onto the first 10 inputs. 10 rows of your input will be shown over there. Otherwise, if you are giving here number like 5, 10, 20 like that, 20 inputs rows will be shown over there. For example, when we are showing, so how it will be. Okay, one more line also we will see, and then we will come here. What is the third line? Once you do this, then third line will be raw _ data describing the data. So it will describe the data as its distribution is linear or it is going to be exponential. So the raw _ data describe will describe the data. The describing the data will give you the basic statistical feature like mean, median, mode kind of things can be easily given. And raw _ data is our variable where our data is taken. .plot will draw a plot, and this is called data visualization step. Describing the data, plotting the data is called visualization. So how are we visualizing the data? We are visualizing the data like this. So which means data.plot, kind is scatter, x equal to size, y equal to price, and figure size. So it is a linear data. I'm coming to a conclusion. It is not exponential data coming like this. It is a linear data. So simple line equation is more than enough to work with this 97 input data that I have taken. The house price prediction of size of the square feet houses are given, and the price in lakhs are given, so that the data is plotted here. See, you can understand that here the x scale, x axis, y axis is price, because I have given y as price, x as size, I have given x as size, scatter plot I have used. But what are the other types of plots are available? There are many other plots, bar plot, scatter plot, or many other pie chart. Many plots are available. Better scatter plot can help me to find the data points to be plotted, so that I can find the distribution well as a data scientist. So this is what the size, and I am viewing that. Now see here, you can understand the house prices are given, square feet are given in some range starting from 500 to some 1000. What is the highest value here? Minimum, maximum will be 22220, or some other value may be minimum. Minimal value may be some lesser number starting from 500. I'm not seeing any 400 here. So automatically the visualization will give you from 500 it will start and it will go to 2250, like that it will go. But for computation purpose, I would like to normalize it to 0 to 1 or something. I want to normalize it. What I will do, the thing is that normalizing formula will be given. See, up to this I am calling it as the data is raw data. So now I am making my data as a normalized data, which means the scale will differ. Raw data minus raw data mean. See, taking the mean of the data, numerical numerator, denominator you take it, take x as the raw data, x minus the mean of the data divided by the x data, x dot maximum minus minimum. If you take, this is called a standard normalization formula being used by the statistics people. So I will come here so that you can easily understand. So how to run the code is given here, run all, or separately also you can run. Data pre-processing, we are in the step called data pre-processing. So to make all data in similar scale, or any missing data available, we have to fill it or delete the data in order to avoid or underfitting the model. Underfitting is nothing but the data is not enough to train the model. Simply I have taken 5 data, is not good to predict. Or overfitting is nothing but your data points are having more noises, so your model will learn noises from data. So see, already I'm telling a small kid bad things, so it will learn from the bad things also. Then will it do a good thing? No. So that is called overfitting the data. So separate inputs and outputs from raw data. I have to separate input separately, output separately. So x will be the n-1 number of column except the last column, and fill up the blank data, anything. This is called data pre-processing. You might have come across these terms from data mining concepts, data pre-processing. And feature is here, size is one of the feature, and the price is the another feature. Or in the multivariate data, room, area, distance from main road, all these things. So this is called feature scaling, or as I told, this is called normalization. You can apply this normalization to any of the data you can take, it will very well work out. Data is equal to data minus data dot mean by max minus min. Okay, so that you can apply. So these two things has been done in the coding wise, Python coding wise, how I am doing. Until up to that, I have called the data as raw data, which is your CSV file taken. Now I am converting the data into raw data to data. So data equal to raw data it is. Now I am again checking the head. Head will give you the output, like how many number of head will always display by default 5 values. If you give 10, 10, or if you give 97, it will show all 97 values. If you give higher than 97 but data is having only 97, it will show only 97 over there. So that is what. And then plotting the data, I have already done it. See here, it is already 500 to 2250. But if I normalize the data, automatically this will become from 0 to 1, or some scale will change. So that is after normalization, you can find the data will change over there. You can easily find over there. And now I'm coming to whether the RAN output is with me. we are already running out of time. So the next thing is we have to model how this is being modeled. I'll tell the y is the output, x is the input. If there are two features called x0 and x1, the model that maps x to y. So I'm simply calling my y equal to mx plus c as theta naught plus theta 1 x, like that I have taken. Now my the theta naught and theta 1 parameters are how they are being built. See, I can very well go on directly use the inbuilt functions, but now I'm helping you to understand how this model is being built, theta naught and theta 1 over there. So y equal to mx plus c. If you vary the m and intercept, please mute all. I'm getting a noise. So 0 plus 2.5, the m and intercept are changing. The line intercept is changing accordingly. So this thing we need to understand. Then any linear equation can be represented for this data that we have taken. The distribution taken is very well fit to this y equal to mx plus c. Error is the predicted output minus the actual output you have taken in your model. So the model will be like this. Error formula will be error equal to f of x minus y. So we have to minimize the error. So the linear equation for a data xi, let's assume the error is ei. We need to minimize this data. So root mean square method or gradient descent function can help you to minimize this error. Minimizing error is nothing but you have to adjust the line equation with intercept and slope so that the line will perfectly fit where each and every data point will be with minimal distance. So that is what the minimizing the error. So squared error, I told mean squared error, everything we can use it. So the squared error is nothing but the error formula will be summed up to square or summation of f of x minus y the whole square, or error can be calculated by 1 by 2m. Here actually any averaging we are taking, we will take the total thing, we will sum up everything divided by number of elements over there. But why 2m means because in the formula when I am going to apply the differential equation, x square function will give 1 2. To cancel that, I am having 1 by 2m over there. So quickly we will go. So find the shape of the data. Then I have pre-processed the data. I have separate the data x from data y. You know, in Python there is an operator called colon operator, which is a slicing operator, so that easily any matrix can be sliced so that you can split it into two data over there and separate y from the data and define the error rate over there. So come to our thing, what happened so far. So data.shape, and then I'm inserting 0, ones. Why am I inserting 0 and 1s? I will tell the 0 and 1s are nothing but here the 0 and 1s are nothing but our see, we have 97 rows of data available, the size of the house, and 2 columns, size and one is price prediction will be there. 2 parameters are there, which is theta naught and theta 1, slope and intercepts are there, 1, 2 is there. So for that reason we are taking the here we are taking all 0 and 1s. I am taking over there. 0 will represent the first column, second theta naught and theta 1 over there, and data and column can be differentiated. So now the point is how to data can be separated. So the last column, slicing operator colon, I am giving 0 colon. See, the first colon will tell that all rows and columns you have to consider, and the second thing will tell that from 0 to n minus number of 1 columns. So column minus 1 will be there. So which means x data. I am taking from the first column to x minus 1. Last column is x data. Y will be colon. I am taking only the column minus 1 to column. That means the last column. So that will be taken separated. I have separated the input. Now see, up to this we have separated the data in matrix format. But for machine learning to make it to understand, my computations and everything will be in NumPy package. So I have to use the NumPy np.matrix. I have to convert my normalized data into matrix format. So np.matrix of x. So x is called separated data, y is called the output column over there. But one thing we have to understand, I told that 0 and 1s have taken. Y means, see, whenever we are going to multiply x with theta, x theta, I'm going to make a multiplication called x theta. Matrix multiplication, the column, first matrix column should be equal to the second matrix row. The column should match with row, otherwise we cannot do matrix multiplication. But my linear equation, theta naught and plus theta 1 is there. So I have to transpose it to 2, 1 so that I can easily, we cannot multiply. So I'm splitting it. So the theta parameter is made like this. Now easily I can pre-process the data, and I can, the pre-processed data can be easily fit into the equation. So this is called the modeling equation, which is theta naught comma theta 1 by 2m. This is called the error function. The error function is y of x minus f of x minus y the whole square. So I need to find the gradient descent. See, this gradient is nothing but you need to apply the differential calculus or differential dy by dx on a particular point. Rate of change with x with y you need to find out. So that is what we are going to do now. So to do this, I'm going to insert multiplication identity is 1. So I'm inserting all ones here and x1 and y here. So automatically we are going to insert 0, 1s and 1 over here. And then the slicing, Python basic slicing, you will easily learn. So I have separated now x and y data like this, and now I converted everything into NumPy matrix over there. Now very well I can go for my data can be separated. X dot shape is 97, 2, which will consist of all ones, and my 97 rows size will be there. Second is 1, 2 will be the size of the theta naught, theta 1 will be there, and 97, 1 will be the output. This is the output column. So this is theta, this is input x, theta, output y. So x dot shape, theta dot shape, y dot shape will be there. So how to write a function in Python? So def is the keyword, def compute error. Error function is the predicted output minus the actual output. So you have to use the keyword, the pre-parameters, whatever we have done so far, x separation theta y will be taken into account, x y theta like this. So np, the numpy dot power function, the total power function, x dot theta dot t minus y the whole square is written like this, then return it will give that. So my function, modeling function will be written as a code like this. Then finally, whenever I'm using the calling the function with a name called compute error, automatically if you supply x, y and theta, this function will compute and will give you the compute error rate it will give you. So plotting the error versus theta. So I'm going to find gradient descent at each and every place, whether every data is being taken, whether the function is going in a positive direction so that the error function is minimal or error is going to be very high. So dou j theta by dou theta. So the theta updation parameter, any machine learning algorithm will have a learning rate. So the new theta can be modified as new theta value. Theta value is nothing but the changing parameter in any machine learning algorithm. So new old value plus the rate of change, because you are applying differential equation over there. So the old value will be minus c. C is the learning rate. So if you fix the learning rate will be very high, you will get less number of iterations, but your function will not converge faster. It will be oscillating. But if you use this c value 0.01 like that, more number of iterations it will take place, but the function will converge well. So the new theta value will be calculated as old theta plus, this is the formula, old theta plus the learning rate multiplied with the rate of change. Every time whenever one data is taken, how you are going to minimize the error. You should not go in the increasing error thing, gradient descent function. So this is one of the example I have given for how to calculate the gradient descent. Gradient descent, always try to calculate the minimal error over there. I have worked out with the theta value. If the function is f of x is this, then if I apply it, I will get some value. So how to calculate it? The new theta can be old theta minus c into the differential value I am taking. So the new theta value you can easily. So this new theta value, if you apply to the function, no, immediately you will get a theta will go to converge to 0. So that means the gradient descent is helping me to find the positive direction where the error will be very minimal. So finding will be at minimal point of error, the slope or gradient becomes 0. So when gradient becomes 0, we have reached the minimum error for that parameter. When c is low, learning rate is very low, the number of iterations will be higher, but it will converge well. If c is higher, lesser number of iterations, but you will stuck up with local minima. One time you will get a good result, another time you will not get a good result. So that is what using this learning rate and the parameters over there and hyperparameter of tuning of any machine learning algorithm over there. Now gradient descent function will be taken. The new theta j plus 1 will be old theta value minus c, and the gradient descent you will be applying. So two thetas are there. Two times you have to apply a partial derivative to the theta naught with respect to theta naught with respect to theta 1. So both should be updated simultaneously. You should not update theta naught one time, theta 1 then, or theta 1 first time and theta naught. Both should be updated. So you have to use a temp variable over there. So the model and the cost function 1 by 2m already we have taken. This is the error function. Gradient descent is whenever we are applying. So automatically we know that the differential dou theta naught wise when we are doing 2 into, so this 2 will cancel. Automatically you will get 1 by m. F of x minus y, like that you will get with respect to theta naught parameter gradient descent. And theta naught formula will be now updated with theta naught equal to theta naught minus c into 1 by m, like that the function will come. Similarly for partial derivation with respect to theta 1, when you are calculating, automatically 2 will cancel, 1 by m, and you will get the value like this. So that finally you will get the formula like this. Theta 1 formula will be like this. So theta naught formula is theta naught minus c 1 by m. So these two equations will be used for coding in my equation over there. So that is what I have done used in my gradient descent. So the error is nothing but x dot theta dot t minus y. How the multiplication things I have done it. So to make you to visualize how this is being done, you will watch my. So we found from partial derivative theta naught theta 1 updations how it is being happen. The gradient descent function is written by me like this. Def gradient descent is a way of writing. Written theta and cost will be written as a output. The gradient descent function, how each and every values are taken one by one. If you take it, the explanations are given. Gradient descent x theta and all, how creating the temporary matrix, and then how these are all being updated, and creating an integer called parameters, how this is being done. How to write a for loop in Python and use it for writing the iterations over there is given here. This formula, how it has been converted into equation like this in Python coding. In that way, whatever we are thinking in a formula wise need to be converted into coding to test the data. So, and then the parameter changing and everything will come here. Finally, the complete formula here I have taken the learning rate as 1 and iterations I have given 150 iterations I have given, and now the gradient descent is running, and it will give me finally it should give me the g value and the cost value, gradient value and the cost value over there. I'm passing x, y, theta, my learning rate called c, number of iterations as 150. Now what is the cost I am getting? So the final value of theta after completing the iterations, cost of all iterations I will get it. So now plotting 100 training data and our prediction how it is being come, and then my iterations, number of iterations, cost, whether the cost is converging or not. So if it is at a certain point, it is converging, that means there are no more changes in the function. So you can stop it. So which means that the model is very well learned with the data, input data taken. Accuracy, how to calculate the accuracy and prediction will be, you have to write a code. So for that, scikit-learn package will help you. Scikit-learn metric import R2 underscore score. If you use it, accuracy also can be printed. Similarly, prediction. So I have to write a predict function, def predict function. I'm writing, get the input from the user, enter your, because already our machine is learned with a good lesser minimal error. Now you are asking the user to give your size. Some user is giving 780 as square feet, and he is asking the model to predict what will be the price of the house. So everything will be taken into account. Again, this will run the new theta parameter. The tuned theta parameters are all there. No, already 97 inputs are given, already taken, and the target function is already approximated. So in that, this will be applied, and you will get a new price over there. So automatically we can easily calculate the new price over there. So this is what the way how to predict theta and accuracy. You can predict using this function. So mean normalization also. See, already for taken data, we have normalized and given as an input. Similarly, we have to give a normalize. So this code is giving you the overall thing. Here I am separately explaining every 2 line. I am explaining mean normalization. Input also should be normalized, and then it should be given as an input to the model. So automatically the price, new price will be predicted over there. So it will give the new price predicted value. You will get it. It will be between the new price from 8 lakhs to some 12 lakhs, like that you will get the output over there. So this is what, how to use the linear regression for only prediction problems. Linear regression cannot be applied for classification problem, because classification is discrete. Linear regression is the continuous values over there. So this is what the linear regression. I hope I have almost done over there, and any queries you can ask me. Any queries?
Hello, Dr. Vijaya Rajan.
Ma'am?
Good afternoon.
Good afternoon, ma'am. Ma'am, how are you, ma'am?
Doing good. Such a nice lecture.
Thank you, ma'am.
It was very, very informative.
Ma'am, I thought of I can give the deep learning also, ma'am, but most of the people are struggling to start with machine learning. They are hearing the word. That's why I have given enough material to the participants, and I touched the very scratch. The other researchers and other speakers will be advanced topic, ma'am. Thank you, ma'am.
Very good, very good. It was very, very clear presentation, and you went in the details of this regression. And
yes, ma'am. I have given a glimpse of regression, but multiple linear regression and other models, once they understand this, they can cope up with this, ma'am.
Very true.
Yes,
it's a pleasure to have you with us, and thanks for your concern.
Yes, ma'am.
Thanks for giving such an informative and educative session.
Thank you, ma'am. Thank you so much, ma'am. I will take this opportunity to show my gratitude. So spend more time with your family, friends, and nothing is important in life. So enjoy whatever you are doing. Enjoy. It may be learning or anything. Okay. All the best to everyone. Happy Teachers Day once again to all, ma'am.
Yeah, very happy Teachers Day to you.
Yes, ma'am. Thank you, ma'am.
Thank you. Thanks for your time, and thanks for your efforts. And let us get connected on more occasions in the coming days.
Yes, ma'am. Yes, ma'am. Definitely. In other topics we will meet, ma'am.
Sure, definitely.
Thank you.
Thank you very much. Participants, you can raise your questions and get your doubts clarified.